Yes. Hello. Hello. Can you see us? Can you hear us? Oh, good.
Yeah.
We can hear you too. Justin's coming from his school, so he'll be here soon.
That is fine. Before we start today, I wanted to talk to you guys about something. This is not related to this project, but we are submitting a proposal to the NSF to do some curriculum writing around computing and Algebra 2. And we will have a teacher advisory board, and it will be mostly teachers from the Boston area, but I thought you guys might be interested in being part of that board. I think it will meet once a month. I will have nothing to do with the scheduling. So it might meet every other month or something, but the idea would be that we would run the materials past you guys, and you would tell us what you think, and that's it. You don't have any further responsibility, but we don't want to write the curricula will be tried in schools. I think we're not going to try in New York, but we do want more teachers than just the teachers who are in the trenches to have their eyes on it. So if any of you guys, if any of the 4 of you are interested, send me an email and let me know. So the main thing that we would need from you right now is just a letter saying, yes, I would like to be on this board. And I'll send you all the text for that. You just have to put a signature on it. But when we were talking about teachers for the advisory board, I thought you guys would actually be a good collection if you're interested. And there are a lot of our curricula in New York right now, Beauty and Joy of Computing. Are any of you guys using that?
No.
This is really just trying to use some of the computing principles that we use in all of our computing curricula in Algebra 2, so that kids who might not get an opportunity to do computing outside of math will have a chance in Algebra 2, and kids who tend to be pretty turned off by Algebra 2 might find something to interest them in a year. So my colleague Al Coco, who's PI of this project, taught it at a school where students really struggled to find any meaning with Algebra 2, and Algebra 2 enrollment went up once he started teaching computer science built in. The students didn't ever ask, like, why will this ever be useful to me? They just believed that computer science was useful. So again, just shoot me an email through Abby or on your own, and let me know if you're interested. There is no pressure here. It's just if that's a subject that interests you. It's not going to be a huge teacher advisory board. We have a couple of teachers from Boston, and I just suggested you guys as any subset of you, I think would be really great to have on board.
Do you need to have like a computer science understanding, or?
And in fact, I think
in
some ways it's better if you are straight up an Algebra 2 teacher and you don't have a computer science background, because the last thing we want is to create materials that are only accessible to people with a computing background of some kind. So obviously we're not going to turn people away, but our goal is not to have, we'll have professional development around the materials for the teachers who are piloting it. But that, again, that's not going to be you guys. That would be teachers in the Boston area for now. But I think it would be great to have your advice. And it's paid, and I think it's a really nice opportunity to interact with other teachers around some of these ideas. And I think we would try to use Zoom. I don't think we would use Google Hangouts, but I'm not sure. So you would just have that like Brady Bunch effect of the different teacher advisors. So you could actually hear everybody's voice. It's a little different than doing math separately, because you would all be participating as advisors. So we'd send you the materials to review, you'd review them, you'd weigh in, and then you'd be free. And I think one of the things we found with everything we've written is we especially need people to read from the lens of students who don't want so many words on the page. So like just hearing from people who are in the trenches right now, like this is too many words on this page, is unbelievably valuable. So it's a fight that we fight all the time, but even though we know it, we still need to hear it a lot. Okay, sorry about all of that. Work on your opener.
Great, and we're problem set 4. Yeah, right?
I hope so, because that's what I'm planning for today.
I think so, but then I was like, yeah.
Yeah.
And then next week, problem set 5. Okay. So problem set 4.
And Abby, one thing you're going to want to have open is the spreadsheet for.
Okay.
Here, I'll send you the link.
That would be amazing. I know. I'm sorry. I can't keep track of all the.
No, I know it's really hard. Believe me. Before we.
I'll do the same recordings, even as if like I'll do the same things that I've been doing.
Perfect.
Okay.
That's good. And actually today it would be a little better, I think, if you text me the pictures because my email isn't working very well.
Oh, sure. Yeah, just send me the number.
There's my phone number.
Okay. Cool. Okay.
Oh, one last thing. When you're working on the opener, I mean, this is the best day so far, really. So and one other last thing. It's been so long since I did this one. Who has any memory of what modular arithmetic is? And so far, almost nobody has in any of the sessions. So if you need a refresher, that is just like everybody else. So just as a quick refresher, the most common modular arithmetic that we all do is with a clock. So imagine a clock that starts with 0 instead of 12. And if it's 9 o'clock and you want to know what time it's going to be in 6 hours, you don't say, if you're not in the military, it's going to be 15 o'clock, right? What time do you say it's going to be?
3 o'clock.
So you're basically just winding around like a clock, right? So what is 8 plus 8 mod 12, which is basically if it's 8 o'clock and you want to do 8 hours later.
Before.
Mm-hmm. Great. And so that is like a traditional clock. Now imagine that it's a clock that goes 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. That's called mod 5, just like the regular clock would be called mod 12. So what is 4 plus 4 mod 5?
3.
Yep, you got it. And what is 3 times 4 mod 5?
2.
Great. So that is addition and multiplication work exactly the same way for mod 3 and mod 4, which are the mods you're going to work with today. So you can just start filling in the table. Oh, by the way, in the margins, it says mod n is just a fancy way of saying the remainder when you divide by n. But that is really what we're doing, right? We're like taking all of the multiples of 5 out. Like when you did 12 mod 5, you took out the 2 multiples of 5 and you were left with the remainder of 2, right? Okay, go for it. I'm going to mute.
They stopped me at the security desk and they're like, "Where are you going?" I was like, "Shit." They were just like, "No, hey." And they're not okay.
Oh, that's good. Powerful, right? No. I want to check mine. Oh, thank you. Yeah, exactly, I know. Okay, I can do this.
Does anybody want to compare grades to see?
Yeah, I think it would be good to check with each other. How far are you? Roughly.
We're almost all done with the grids.
You're all done with all the grids?
Almost.
Okay, just take a couple more minutes and finish those up and then check them with each other or with me.
So usually on both sides of it, like 1 and 30 will be 0. So like 0 choices. It's not symmetrical, but very, I guess, compliments.
Sorry, who are you giving a compliment? I'm open.
I'll just say that.
Never mind.
Thank you.
Never mind.
Fearless.
Didn't work.
So these complete each other.
I'm not totally getting it, but
So like. I
didn't mean like that. I just
no, I think whatever I was saying.
Well, I see that. This.
I'm just gonna read this way. Instead of that. Yeah. I would read your paper. Not go to your paper.
Well, I decided that I was only gonna do the bottom half. So I was thinking that 0, 1, excuse me, would be the same as 1, 0. And I'm critical. So, okay. This is the best yet. I noticed there were no 2s in C or D.
Yay, that's right. There are no 2s in C or B.
Which made me feel
C or
like
D,
really
right?
weird.
In C or D. And what's missing in D?
3.
Mm-hmm. So what could that mean?
X squared plus y squared minus xy can never be 2.
Mod 3. Mm-hmm. So yes, it can never be 2, but what else can't it be?
Anything else that's 2 mod 3.
It can't be anything that is 2 mod 3.
So 2, 5, 8, 11, or 2 mod 3.
How can that be true though? It's not real.
It is.
Like that's
Well, why not? So you guys have a chart that you can use to see if this is real. Like, and you spend a lot of time on it. So do you have that link open, Abby?
Oh,
I do.
do you remember when we
I
blocked
will.
out all those columns? Right, that's what we're talking about? That was the 2 column, the 5 column, the 8 column, the 11
Will you send me that again? I
It
didn't-
should be, look in the group chat. It should be right there, right above my phone number.
Oh, I'm using 2 computers, but, oh wait, I'll pull it up.
Oh, and keep this, B has no 3. Do you agree? And this thing.
Can you all see this?
There's no 3.
I'm gonna make it larger.
X squared plus Y squared.
This is ours, yeah.
I can also share my screen, Abby. Okay,
No,
you guys.
Actually, I got it here, I think.
And there's no 7. And there's no
We're just
11,
looking, just so you know, we're projecting the
right?
Baldwin
There's no
screen,
there's
yeah.
no-
Perfect.
of that spreadsheet.
Perfect.
That's-
Take notes. Sarah, happy Pi Day.
Oh, yes. Oh, my gosh. Yes. Happy Pi Day. This is such a great day to do Pi Day, even though this has nothing to do with pie today.
No.
But
But we're
it's such a great day because look at what you guys are actually seeing, right? Like all of that work. And do you remember when people were like, why are these all organized in 12s, right? But do you see why this is all these charts? Hold on, I'm going to pull up the Baldwin. Do you see why they're in 12s?
Well, let us think about that for a little bit, because I think,
Okay.
so the
Yeah.
question is, why are the 12s here?
So that was a question that came up often, right? Why are the 12s here? And think about that.
Okay.
Why did Bowen, who has reasons for everything, arrange the table in terms of 12?
Well, it definitely looks better with,
Times 12, okay. So our ultimate goal, I don't really understand it, but I agree that 3 times 4 is 12.
Oh, yeah, I got an idea.
Okay.
Table D has no 2s, right?
No,
So
two.
similarly, you could say, you're never gonna get 2 with x squared plus y squared minus xy, nor will you get 6, nor will you get 10.
Because you're adding.
Because it's mod 4. So for mod 3, we have 2, 5, 8, 11. And for mod 4, we have 2, 6, 10. Combined, that spans all the columns we couldn't get. Right
So
over there,
using
like 2,
these-
5,
oh,
6,
because the
8,
way-
10, 12.
The way we got this was, where was this coming from? X squared plus y squared minus xy?
Yes.
Okay, I think I just made it.
I also think I'm not. I'm not.
Oh, you want him, so we did the same table with this, except we subtracted x y. Okay. Yeah, yeah.
So many colors, guys.
Yeah, no, this is like another version that we did the same exact process. But we didn't have as many, I think we didn't have as many realizations, and we forgot about thinking about how we're going to think about it the first time. Which I now really don't remember.
But this is showing us why that table makes sense. Presumably. Right?
Maybe not all of it, right? Not all of it, but a lot of it.
And then use 11, 12.
Mm.
Just asking why we stop at 12 and start. And then create the chart to stop at 12.
So maybe we could see,
Well,
Well,
so that we can see the patterns.
yeah,
Because if not, it wouldn't align. It wouldn't be.
the line. Is 55 supposed to be highlighted, you think? Feels like it, right?
Well, except there could be an exception of. 55 is 5 and 11.
Oh, okay.
And 5 and 11.
Right.
And wasn't there a group that was not ours that said something about like all of the product multiples of 11?
Are
Really
okay.
good.
Yeah.
Pretty,
What's the-
pretty good.
What's the color, please?
I can move it so we can see. Maybe we labeled it, but maybe we didn't.
This is sessions.
You know what? I think
We weren't good at that.
I think that because you weren't here, we were not good at that. We couldn't we couldn't be good at
That was
everything with that. That was not spiteful.
She's not gonna catch
And some of them were-
No, it was just
No,
like
wait.
we needed the fourth brain to help us. I don't think the colors actually meant anything, because if I remember correctly, I was recording that, and it was just like the first round of things we found, and the second round of things we found. And it was just like, okay, well, I don't know. So we kind of answered number 1, right? Food. Well, how food using one of the charts.
Well, we use part C, right?
I think you don't, I think we don't have to write down a full and formal proof right now. I just want to know if you guys believe it. Do you? Do you believe that there is no way that anything that is 2 mod 3 can be written in that form?
I believe it.
It's in one with pudding bowl, I'm pretty sure.
Really?
You see my proof is in the pudding bowl? There are bowls that have proofs at the bottom.
Oh, that's.
Or no, they're bowls
Oh,
that
yes,
are
yes.
here on the outside, but proof is at the bottom of the bowl, because the proof is in the pudding.
You make pudding that often, or you just eat cereal in it, like are you baking the
The bowls
rules?
are like this.
Okay, we're moving on to number 2, because I think we got number 1, right? Is everything feel good? Just 2 mod 3, we can't do it, we can see that, we can see. Okay, so do we wanna, for number 2, we had started this last time too. And, do you want some time to work on it, or do you wanna talk about it?
This was the geometric thing with
Why don't you work through these, actually? I think they're a little easier to do independently, at least at the beginning.
I don't remember doing it that way. I remember it was some kind of conjugate.
yeah, don't you?
But I don't remember, I don't think you're wrong, I'm sure you could do it, I just don't.
I thought it was a connection. Is it? Don't you multiply by like, if it's.
That's what I remember doing, but I don't know that.
I think they want us to do the process to figure something out, so go ahead and do some of the distribution.
This.
You guys didn't really seem that amazed about the 2, 5, 8, 11 thing. Were you not amazed? Isn't it amazing that that should be so?
I think it's cool, I guess. It's not that I don't believe it, it's that I feel like I'm still processing how that could actually be true, it feels like. You know what I mean, it's like a weird argument.
I think it's also a big thing we learned really quickly, so maybe.
It's a weird argument because you wouldn't think of it, right?
Yeah, if I was trying to convince someone or even trying to go about like proving any of that, it's like definitely not the direction I would use.
Right. It's not a natural place to go if you're not used to doing that. But it's still amazing that if you actually just translate the whole thing into mod 3 and mod 4, you get so much information.
Mm-hmm.
I'm getting a negative 13.9.
I got 22 minus 13.9 over 3. I got 26 minus 13.9 over 3.
Yeah, that's.
Oh,
I
so
got
no,
you.
you guys are right, I just don't know that. Oops. Oh, then you get rid of the fraction, that's easy. That's 2 minus 5.
Yes. This is one of those times where, like, if we did this in the morning, teach me. Yeah. It's easier. I'm gonna try to do it in my head.
Silly.
Sean.
Yeah, it's really inspiring.
Is the next one 3 plus 2i?
Oh, wow. That's what I got.
Yeah, because isn't A and B are just opposites,
Oh.
right? Don't we know that 8i, like, you get what I'm saying? 8 plus I over 3 plus 2i equals 2 minus I. So if I just like, okay,
No, I don't understand, sorry.
alright, no, I'm
The
sorry.
numerators are the same, so then you're just switching the answer with the.
Oh, okay.
Right, so we know that 8 plus I equals 3 plus 2i times 2 minus I. So then like you can divide by whatever you want and then get the other one.
And I have already, so it's 3 minus 2i.
Or maybe I should do the math and not be so lazy.
No, that's fine. Oh my gosh, I just realized problem set 4 on here, it says that it's Pi Day on here. Oh my god. Was that from you?
No,
But
if
that was
only.
randomly also Pi Day?
I think when Bowen piloted these, it was Pi Day when he did this
Well, it's
session.
fine. It's years later, with however many years.
It is amazing that it's Pi Day. In fact, I'm going to take a picture of it and send it to Bowen right now and tell him that you noticed that. He'll be so happy.
Also, us 3 here are going to PCMI, we should tell him that.
Yes. Okay. If you're going to PCMI, then you really, wait, Abby, have you been to PCMI?
Us 3, so Shauna, Jasper, and I have been
Okay.
before,
Yeah.
not before, well, Shauna went a different year last year. And Jasper and I went 2 years ago. This year, Ishrad's coming with us.
Yeah. All the more reason you guys should be on our advisory board. Really. That's great. All right. I will tell him that when I send him this picture.
See, it's 5 minus 2i. You don't want to do it.
I really started.
It's just, yeah. Let's start with you.
Because I just didn't go in alphabetical order.
Wait, we can divide out stuff by AD, right? What's my third?
Can you though?
We could factor 10, 13.
Oh.
Yeah, 10, 13 plus
Gotcha.
2i.
So the
Oh,
answer's
10.
just 10.
Yeah.
Abby.
I don't think
I
I
don't
solved a
always
single
see
one of
that.
these. Everyone told me the answers for all of these.
Well, we're not moving on until you feel like you have. So I'm gonna write in our notes that we are feeling good about
Conjugating verbs.
conjugations. Wait, I'm not seeing. I'm just gonna add a row.
What is, I think there's a reason for each. We found A and B, no D.
Well, C was 5 minus 2i.
Baldwin, this is
We have
problem
to
set
get it
4.
out.
Okay. Bowen says, that is amazing.
Yay!
So it's not.
What is it? Is it a mod?
It's 1. Mod, oh.
Mod 3?
Mod 3, it's 1. Right? Yeah. 43 is 1 mod 3.
I don't know what we're talking about, to be honest.
Well, there's a reason why they pick these numbers. We can see why, if you notice A and B, right? If you just take out 10, that's that. What about that?
So you're saying-
Besides the generic way of doing it,
Yeah.
why would they put that?
And what did you guys figure it out?
No, I mean, the answer is 5 minus 2. So I'm thinking,
Are you guys working on number 3?
No,
We're working on 2, but maybe 3 would give us.
No, don't go to 3 if you're not quite done with 2.
Well, we're done with 2.
Okay.
I want to understand why
Oh.
C is there.
We're not done with 2.
also I'm going back to 1. I mean,
And
no,
you're going back to 1. Great. That's great.
no problem.
Okay.
You can do it. I'm
No,
I'm
no.
going all the way back. Because
Shauna, do you wanna?
I feel like it's,
Oh, wait, well, we've solved two.
We have solved 2, but we wanna understand it.
I like 5s.
Two and five, no.
Can I say one thing before we just totally move past this thing that I was thinking about? In
Yes,
the opener,
yes.
we were looking at like, I mean, you guys could say no. We were looking at like 2 mod, whatever, mod 3, right?
Mhm.
If I take the calculation x squared plus y squared minus 2xy, and I look at our grades and I notice there are no 11s, right?
Wait, why is it minus 2xy now?
Or
You mean
no,
just
no,
minus
no.
xy?
Okay.
If I do it mod 11, what is gonna happen? Because I don't want to do it because it's like a lot of boxes, but I'm gonna do it. It's gonna be cool. You guys get what I'm saying? Like,
So
there's no
you want to
11.
do this mod, you want to do the calculation x squared plus y squared mod 11? Is
Yeah,
that-
but then I have to do 0 through 10 and 0 through 10, which is like a lot of times. 121 times.
What's that?
I also think that's a pretty big table, by the way.
Because it's 2, 5, 8, 11.
But I'm saying like 11, 22, 33, 44, 55. None of those are colored in.
But
But you don't think it's gonna
also-
matter?
I think it's still 2 mod
11 is 2,
mod 3.
not 3.
You can like condense.
But 22 is not 2 and 3.
Not 22, 23 is.
Right, but I'm thinking about the multiples of 11.
Oh, so you wanna find out so we
I'm
can
saying-
color code to see which ones are not true because of our 2 mod 3.
Yeah.
And then color code for which ones are not true or whatever else we could find. Or no, you
Sure.
don't wanna do that.
I don't need to do that. I'm just wondering if you did the table mod 11, if you would get a weird result that would be connected to the fact that we can't get into that table if we did the table.
I say go for it.
Yeah, how about you try that table? And Donna, you're gonna color code, you could change maybe change all those gray ones I couldn't. from last
Change
time.
these to gray.
Yeah, just so that it's then,
Well, is there a reason why there's this color and not that color? No, right?
I don't think there's any reasoning behind those colors.
Are you guys looking at the x squared plus y squared minus xy table? Oh, you, okay, yes, you are. Okay, good.
The thing for it, but 51 minutes. Okay, so then, sure, do you wanna do that?
It's okay, mine.
Oh,
Unbelievable. You better. I'm gonna need all of these calculations.
And then I can stay here.
Can I hit you up for
yep.
Yeah.
Okay, don't worry about it.
We might have
You wanna use
one.
the computer?
Yeah, I do.
Okay, so this is gonna be. Okay.
School bus computers. Just yellow ones that are extra.
Mm. And then, is it mod 4? Is there another one after this?
Yeah, 2 mod 4.
So 1, 2, 3. All right, hold on. I'm gonna do color coding worksheet.
That's what I did. So how can we use this calculation?
4. Does it just go in order? Like, you know what I mean? Like, they did 2 minus I, 3 plus 2I, 4 plus 3I. 4 minus 3.
I'm gonna wait to see what you get in your
Okay.
Okay, I made 20.
Well, let's try to make it blue and see what.
Or if it's 25. So maybe 4 plus 2. 16 plus.
Oh wait, that's 19. I got it.
16 plus.
Sorry. 4 plus I.
Right.
So 19. So the 5 is too big. We know that, right? So you start with the square that's close to it, and then how to make
So we want like 16 plus. Oh, that's not.
What do we have? 16 plus
8.
3. That's
So 9 plus.
size have to be low. Over 15. Okay, so then what?
I realized that I don't.
We have 1 plus 18.
So there's 19 not possible.
Oh, impossible.
What is 19? 1 mod 3. Oh my god, it's 1 mod 3.
We have 17, but 17 is 2. Sorry, it does. So then 65. So if we start with the closest square, 64 is 8.
So 8 I.
That works, right? Yes. Shall I roll again? Or you're still going to see
Plus 2 I.
because that's 4. Yeah. So basically, if you square, x squared plus a square. Right?
Plus a square. Oh, yes.
If it can be written in the form of a square plus a square, we're good.
Yes.
Which goes back to our very first chart.
So the ones that can't be written as x squared plus y squared. 19. Plus the 1 and 1.
As sum of squares.
19 is in this one.
How do we know then if we can write it? Oh, that's our chart. Did we come up with a rule about when we can write it as a sum of squares? So I'm gonna write, this goes back to.
Thirty-three. 21. What's 133? No. Everyone can as well.
Or do you need to check like?
you have to.
Yeah, just to show. It's okay, because I think it's important to show that we're still.
Okay, great. Thanks for sending those. Oh, they look really good.
Happy having with all of us. I think I had a lot of fun, huh? I did.
So by the way, so far in the table, there's no zeros, right? Here, let me share the picture.
Sorry, you're talking about the Baldwin,
I am talking about, here, hold on, this photograph that you just sent me.
Is that Jasper's work? Sorry,
Jasper's picture.
Yeah,
I
there
actually
are no
can't
zeros.
see-
This is exactly what I'm talking about.
Yes, hold on. Let me just share it.
I didn't want to ham it up yet, but I'm very excited.
Okay.
All right,
We're about to see Jasper's question.
hold on. Why can't I? All right, I'm just gonna share my whole messy screen, so forgive me, but see it?
Oh yeah, we can see it. Oh, that's weird. I can see me. Sorry.
Yeah, it's weird. Yeah, it's really weird. I'm sorry.
You want to know what else is really cool? There's this line of reflection within the 11 that starts in when x is 0 and it reflects over like y between 6 and 7. But then when x is 1, it reflects when y is 6. And in the next table column, which I just did, when x is 2, it reflects between 6 and 7. What? Yeah, I'm really happy with this. Here, I can show you guys in the paper too. So this is like the same thing you're doing for these, but like a huge amount. But right here it reflects between 5 and 6, 3, 3, 5, 5, 9, 9, 4, 4, 1. Right here it reflects around 9, 10, 10, 2, 2, 7, 7, 3. But right here it reflects again around the 6, 6, 8, 8, 7, 7. That's weird.
So where's it gonna go?
The line of reflection is getting higher, and presumably it will be right here.
Mm-hmm.
And like a little halfway guy, and then right here. Then you won't even see it anymore.
Yes, because you are creating different parabolas, right? When you fix 0.
Oh, yeah. I remember.
Okay,
Yeah,
Shauna made
yeah,
this
yeah,
sweet
with that three-dimensional
representation that, to be honest, I have no idea. It was like all of these parabolas.
But Jasper, the thing that I think should be making you super excited here is there are no zeros, right?
So that means that there are no multiples of 11 that you're like achieving.
Excellent. Well, I think you have to fill out the whole table to be sure.
Yeah, I mean just half the table. It should be reflective.
Yes, it should be symmetric in some way. That's right. But you're not quite there yet, right?
Correct.
But you can see the symmetry too. You can see the XY symmetry in what you've already done. So you don't need to do the whole table.
Agreed.
But
yeah, I'm actually I'm gonna take a break from this, but I'm very excited.
yeah, so now that is a natural way for you to test these things because you just did it.
Yep.
Okay, there's something I noticed. Let's hear it, Shauna.
I don't understand the A value. So these are the things that I stay with. I'm trying to understand why they picked this.
Yes. Number C, letter C specifically.
Right, there's a reason that you can see A and B, but no D. There's a reason to see. What are the reasons? So the only thing I can see so far, looking at the complex number A plus BI, and I understand how to get B. So there's always, to get this value, it's this minus that.
Wait, can you say that?
Yeah, so this is 1 minus 2 is -1. 1 minus -1 is 2. 6 minus 4 is 2.
Which is part of our answer.
This is part of the answer. It doesn't work for this because this is not imaginary. It's not imaginary. If the answer was imaginary, it would,
Always?
unless it's coincidental. Just kind of weird. It could be the
Let's
reason
choose-
why C is here. I don't know A. Unless it's random.
Oh, wow.
And what, it feels random, because can we just choose any numbers?
Here,
Let's just choose
choose
any
two.
numbers, yeah.
Give me 2.
5 and 7. But don't you need 4 numbers?
Yeah, I'm gonna give you 2 expressions. 2 complex numbers.
5, 7, 8, 2.
5 plus 7, 9 over 8
Yeah,
minus
this
2
would be
y.
really-
If you want.
Or it could work.
I'll do the
I
same
would
thing.
be more.
Yeah.
That
I
would
think
be
there's a
wild.
I'm
I agree.
confident that they would not choose this problem.
Yeah. 43 and 7 are.
These numbers are coming from somewhere. And right now, I'm like, could I figure out the answer was 5 by these numbers? Right? Like if I add them, I get 50, you know what I mean? Like divided by 6 plus 4 is 10. Is it 50 divided by 10? Is that how I'm gonna get 5?
I'm just looking ahead to see if there's like, because you know how sometimes you start seeing the same numbers a little bit?
Yeah.
Because I'm wondering if it's like something about like 43 C.
Wow. I got 67 on.
Maybe I'm testing it to make sure.
Mine was a weird fraction.
Mine too.
Well,
But maybe it, well, it could
maybe
be
there's something
coincidental.
special about the numbers they picked that we don't know.
Yeah,
They usually do.
it's definitely
Alright,
true.
I'm just gonna keep going, maybe because I see a relationship in B, A plus BI, but I don't see an A. That's one to share. I'll keep going. Because yeah,
And also kind of why D is there, is that just to remind us that we could.
the answer is not complex.
Okay, that we could have a non,
Okay.
just a reminder for us.
Yeah.
Okay. Well,
So if I add, to get 2, if I add these, what I do, add these and sum of this. Sum of this divided by sum of this.
Did you guys get all of these things that have like hypotenuse, type square root of 19? Right, you're doing x squared plus y squared equals things.
we did number 3. That's what we-
Yeah, but when you're answering it, aren't you fundamentally answering like x squared plus y squared equals?
Yes, you are.
No.
Yeah, we
We wrote
figured
it
that
down.
out.
Was I not supposed to say that? That's what I was asking.
It took us a little bit of time, but we figured that out.
Well,
No.
okay, all right, I'm sorry,
No, no,
I'm sorry,
no.
I'm sorry.
Green on the 3.
We figured that out.
I'm
We were
sensing that.
excited when we figured it out.
No idea,
See,
very clearly.
it's-
Faux pas, huge faux pas.
It's a,
Okay, but I have a question. Did you guys get E?
No.
uh-oh.
Did you have it?
Well, I just trust it. Like, I was kind of over it once we made up the rule. And then it was like 121, right? You were
121
thinking about it.
plus 12, 100 plus 33, 81 plus 52, 64 plus 69.
Oh, because you're looking for, we're not, obviously not even going to the world of decimation.
No.
I'm just asking, I was a clarifying question.
So 133 is special because do you guys have the x squared plus y squared table up?
In 10 seconds.
I don't have it up, but I will. I am gonna
Oh,
pull it
no,
up.
x squared. Oh, no, I have the minus xy. I have,
But just pull up that. Just
Wait.
pull up that table too.
we have the paper copy in our giant folder.
That's great.
So this was x squared plus y squared, so 133. Where would 133? No, that's not on the table.
It's not on the table, but if you just look at, let's see, I'm looking at the Nantucket.
What is 133 mod whatever?
It does not, spoiler alert, that does not help you.
Um,
So what are we looking at the table to see here? Squares, what numbers we can write? Oh, could we do two? Oh, could we do like two sets of squares? No, it's not.
what were you thinking?
If we did two,
Yo.
some of the squares, and then add some of two sums of squares.
You want to make some sums?
Yeah.
Which keep this banana parade. 133 is 1 mod 12, which means that it would live in the first column.
And
We know
everything,
all of those numbers.
I think 133, just to save you the pain, and since you guys already did quite a bit of that calculating, it's the first 1 mod 12 that doesn't work.
Oh, so it's true that it doesn't work.
It's true that it doesn't work. But somebody in the second session asked me, like, is it always, so somebody had a conjecture, I don't think it was you guys, I think it might have been Oklahoma, that they didn't say it like this, but anything in that one column was going to work. But 133, the specialness of it is it's in that one column and it doesn't work.
So that's good.
So that's why it's there. But it's really a stinker because it's not, you can't use any of your mod tables to do it. And I think Bowen put it there just to tell the people who had guessed that that would work, that anything in the one column was doable. It shows up again.
So that means that Jasper should probably keep going on his table.
But it's not,
Where
it's not 0 mod 11. Right, because it's 121, 132.
Thanks for the backup. I'm not finishing the table.
It's fine. I don't care if you do or not. I'm so happy that you started it. All right.
Okay, so I think Sean is
Would you
working on
like
number
to
2. Oh, okay, do you want to jump in with number 4? We're gonna move
I
on
asked
to
you to
number
call
4.
them. Let's go. Oh my goodness.
I feel
You're
like I
terrible.
want, well, I kind of want
I want my own table. I want that.
is there a reason I should graph these? In order, oh, I see.
You don't need to graph them, no.
Right? Why don't we Pythagorean theorem them?
No, I like that.
No,
No,
okay,
no,
right.
that's-
Yeah, let's not have.
No, I wanted to see it too. Okay. So,
What did
oh,
they go
25 and 25 squared. That's how we do this, right? Yes.
Can I ask you guys a question? Alright, forget it.
Just kidding.
Well, I'm thinking about 6 negative 3, right? If I didn't want to calculate that, could I just do 2 negative 1, find that distance, and multiply it by 3? That seems wrong though, right?
You should think about that, Jasper.
Try it out. I found the answer.
It's worth trying. You should do it.
Did you get 15? Did you get 45? Oh!
Oh,
Multiply by 9. Oh,
Okay,
because now it makes sense to you. You can do that. Yeah, you gotta double it. I mean, you gotta square it. Okay.
You mean like triple it.
I did 2 negative 1, and then that was 5, and then I multiplied by 9.
Yeah.
Because I needed 2 3s, because
You pull
if you use 1, it's not enough, use 2.
So closest is C, then A, then I think I got B. But what's 49 plus 16? Is that 65?
I got 65 for D. Yeah, 49 plus 16.
And 64 for B?
I also just made my list by looking at the lines and measuring my fingers.
That's a tough break on 64.
Well, 64 and 65. Okay, so now, in order of their norms.
But Jasper, what about -1, -1 compared to A?
The same thing. Or is it 17?
But isn't that good? Isn't that 2 times 5 squared?
Mm-hmm.
Oh, okay, I get what you're saying. Cool.
Is it kind of-
Or I mean, I could have done that with B as well, right?
Mm-hmm.
0, 1 or -1.
Mm-hmm.
Very cool.
Is it? Oh, the same as 4.
Yeah, because it's just the sum of squares of A and B.
Right. But then it's plus that extra thing, right? Oh, wait, I'm sorry. Yep.
Are you working on 5?
Well, isn't 5 just the same thing as?
Same.
Isn't that nice, by the way, that you have, this is why this is so nice for Pi Day, because this day is all about connections, right? Like you have these complex numbers, and of course it makes sense that the norm of the complex number is connected to the distance of something graphed on a Cartesian plane, but it's still, I think it's still pretty satisfying to see it.
Mhm.
And 6 and 7 are also very closely connected.
Okay, let's pause for a second. Shauna, you didn't have as much time to work on like reading. Do you want to talk about it or do you want to just have some time? I'm gonna move on. Okay.
You're gonna do 6?
I don't know if I buy it.
Wait, what don't you buy?
Wait. I don't want him to
No.
say it. Wait. Don't say the answer yet.
All right.
Sorry, Sarah.
No, that's okay.
Of your ideas.
No, it's all right. I just want to think about it.
I'm doing 6. If this turns out to be 125. I have a conjecture. Write it down. N equals 2. What did I get? N equals 4. Yep. Then N equals 3, 2 plus 9. Because I did the norms. I just do A and B together. Oh. Slowly. And then I have the conjecture. And so.
Yeah, but I did get 2 plus 9 out. I am kind of disappointed. Right? So it wasn't 125.
Why did you want to do 125?
Because I looked at number 7.
Oh.
My cube is the same as so you got this for
I did not get
N
that.
equals 3.
I got 2 plus 9. But I like your answer better, so I'm willing to go with it. Oh, maybe we're both wrong and the answer's 11. That would be awesome. That's what I really want to be right.
Well,
Can we just cheat it out?
oh.
You feeling
Did
11?
you get 11?
Yeah, I did get 11.
Did this count?
Yes. Because 2 times 4 is 8.
Negative 1.
Right?
Not 6. Did you also put 6?
Yep. Yep, I did. That's kind of wild that we made the exact same error. So I'm like much more satisfied.
Nice.
But that does not make any sense to me at all.
It's 2 plus 11.
That's what I got.
Nice.
Which is going to the norm to be 125. That's what we predicted.
Oh.
Ooh.
I didn't look at
I'm like
7, but I
30
can see how to
steps
get
behind you.
from n, the value of n squared. Does this answer n squared? It would be cubed. Depends on whatever this value is. That's going to determine this next one. Right? I'm gonna keep going.
Okay.
I don't understand.
Keep going. How did you figure out it's gonna be 120?
I just looked at number 7.
I did, I looked at 5 to the first power.
Sure, for sure.
This answer to the second power. I just figured it'd be 5 to the third.
That's interesting.
Right, that's why I was disappointed when I got 2, 9, because that's 85. And I was like, ugh.
So I figure whatever this answer is, then it's gonna be squared.
That's kind of wild though, because it also means that the norm function, right? Like if you have something to the power of whatever, that's the same as norm of x squared. That's true, right? That's kind of funky.
The norm of anything squared is equal to, we wrote the same thing.
No, the x squared, the squared is on the inside, now the squared's on the outside.
Okay.
I'm not willing to try to prove that, that seems weird.
Okay, so can we agree that n to the 4, when n equals 4 is going to be 6?
Ooh, I wanna
Do
try.
I have a graph to put out? I like math by agreement.
Okay. Maybe I'll do it just so I can.
The norm is gonna
Wait, are you
take
taking
this.
n equals 3 and multiplying like that into
Alright, 2. Yeah.
And you're getting everything.
Yeah.
Yeah.
Wait, I haven't made this.
I'm going deep on the proof. Just walking away from
Stop.
So maybe
You
there's.
get negatives that.
Just make sure you take a picture.
Oh, yeah. Does anyone have a phone out there? Yes. Okay. Okay, yeah.
Yeah, but it's NPV if it's negative, because,
7 squared plus 24 squared.
yeah, that's like a big number.
That's 625 though.
Why do you have to limit it and say that it's not? 625 is the same as 25 squared, so I could buy that the 7 squared is gonna make up for the 24 squared big number.
I don't actually need, I can plug into.
I don't think so much lately.
No, my battery is.
I was trying to make you buy new.
I bought a new used phone and I had to return it.
Wait, what?
I've only been buying used phones for the last like 4 years. This was the first time I bought a used phone that was like not good.
Where did you buy yours?
Gazelle.com, but they paid commission.
What?
I just-
Okay, so I understand, no, I don't understand this.
Oh, it might, yep, it is 600. The norm is still 6.5 though. Okay, I just don't want the negative.
That's what we do. Okay.
You wanna know why it's crazy? I was modeling it algebraically, and when you multiply something by itself, the real number component, a plus bi times a plus bi becomes a squared minus b squared.
Sorry, I didn't ready for that.
So you're going down, you're not going up. Like we started with 2 plus I, and then it was like 3, and then it came back down to 2. The b is just maxing out, but the as the b gets bigger, the a is going down instead of up. It's like getting dragged down by the b.
Is that why you had a step almost?
Yeah, I tried to graph it, and it like looks really weird. Like, the lines go like this. This is the I, and this is the 2I. It's 3 plus 4. All of a sudden, the I value is getting massive, but the real portion doesn't. It's not doing anything. You know what I mean? No growth.
Then we kind of did 6 and 7.
Well, find all the Therian triples whose hypotenuse just each. So this is a connection I think I'm missing. I understand that this times its conjugate gets to this norm. And then why is that all of the Therian triples?
So if you think about we were doing like a squared plus b squared equals equal to c squared.
Yeah. All the Therian triples. So this,
So it's like the a is one leg and the b turns another. 8, right? Something back there.
sure. Is this, wait, so this goes back to this drawing that we had. Right? Maybe, right? What do you think of it?
Yeah, because this is,
Geometrically?
this is this value squared. 1, 2, 4 squared
Yes.
plus 1, 2, 3, 4, 5, 6, 7.
So are we saying like this is one conjugate, like that's what I don't totally understand. This is, yeah,
Can I share something with you guys?
yeah,
Are you sure?
it's, is it
So-
related to this?
Well, I just proved that the thing that I wrote down was true. So the norm of,
So it's, okay,
Something.
wait, what did you put? Yeah, and then let me.
if you have any,
And Abby, can you take a picture of it, please?
Oh, yeah, I'll send a picture. Wait. Yeah, so this will, let's ask you to slow down. But after. So now, Sarah, that's sending so we can all look at this.
Mhm.
Do you want to join for this part, Chandra, or you're doing it?
I'm gonna join in because I think let's see.
this person is holding up an exclamation point. It's a critical.
It looks like it's coming, Abby, but it hasn't come yet.
Oh, okay, well, we will wait for you to have it so we can all talk about it, but, maybe just, what are you trying to prove?
So I was just thinking about
Oh, yeah.
the norm function. And I was thinking like if you have something, a complex number, and you square it, what's the norm? Okay? And if you have a complex number and you find the norm and then you square it, it turns out this for any complex number. As
Cool. Okay. What did you
I just algebraic. I just took the norm of a plus bi, and I squared it. I got a to the fourth plus 2a squared b squared plus b to the fourth. Whoops. Then I took
Still worked out with that too.
is that's just doing some shading math. And I took the number and I squared it first, and then I found the norm. And then I did some algebra with it, and then I decided they were the same.
Cool. Okay, so we know that you could square the norm or square it first or however.
Well, because the thing I'm really thinking about that would be really insane would be, what if you could take two numbers, complex numbers, and multiply them, and then find the norm. And that was the same as taking the norm of each number and then multiplying. That would be pretty wild. Does that make sense?
So basically, you're hoping this norm.
Yeah, you covered it. You have two numbers, x and y, that are complex. And it would be cool if they were just, if you could do the norm first and then multiply them. It's a homomorphism or a homeomorphism or a morphism, a morpher. I don't know. Isomorphism. But that would be really cool. Anyways, that was all.
That's awesome.
But I feel like somehow it supports this.
Sean,
So I'm gonna do
you
it.
gonna say something? Wait, wait.
I was. I have a question.
Yeah.
Because you did the norm of each. I was just thinking about. If we started with let's say it's not the base case, but I had put in a 2 here. I was thinking, I squared this and got this, which I was looking at the ending, the complex part of this ending. This is the real, like that they were opposites.
So both of you are exploring
The algebraic side.
yes.
Why? Without looking at the next part, I believe that this would be true. The answer would be the same value, leads to the same.
And that always worked.
At least for-
With the one.
I mean, yeah. So this is the complex. You are in this part. This gives us subtraction.
Whatever you were just. What is on the bottom of your page?
Well, I'm still thinking about this one. 5.47.
So you're thinking about like that in connection with the sum.
Oh, they both on 3. Both of them. Yeah, that's interesting. And the answer was more than 5.
And 6 and 4 are both 2 1. And this is true math 3. Oh snap! Amazing moment.
There has to be. What is the difference in 1 mod 3 of these two numbers?
Isn't it 0 mod 3?
Wait, what?
What if
I
we
give you
do Yeah.
If you subtract them, it's 36, which is a multiple of 3.
What are you saying? No, I'm just looking to see.
That could be why at least you cancel out because. It really goes to not very-
I'm gonna give our report, just a second. Does anyone want to make sure something's here? Say.
I'm feeling good about the multiplier. We're gonna call it the multiplier effect.
Yeah, I think you should put that in. It's really interesting.
Is it effect or effect?
I want effect with an E. Actually, can we just do J-effect?
Nope, it's gonna have to be. It just was thinking about the.
Wow, it's the police, the grammar police just rolled through.
Norm. Where N is the norm. It's kind of weird that's called the norm. Shauna is thinking about.
Is that true in regular numbers? I guess it just isn't other true. Like what is that really about? It's like vectors or some ish. Right? Like
Yeah.
somehow like if you travel by one vector, it's the magnitude of the vector, right?
It's like scalar vectors or.
Yeah, like
Scalar vectors like multiply by, they're just like.
it's just scaling. It's like you're multiplying
Yeah,
everything by
it's like a
2
scale
or
factor.
That seems like it makes it a crazy function though, because then I can take any number and make it really small. Like if you were like find the norm of 200 plus 50i, I would just be like no. Instead, I'm just gonna find the norm of like, can I just do this?
But when you just keep doing this work, this way.
But I said no already. Can I do that?
Yeah, can't you?
I'm asking you to tell me. It seems hard to think about it. But the norm of 50 isn't 50. It's 50 squared. So I need to do this. Yeah, you feeling that?
Saying before with the things you,
Oh, and it won't be
Not-
squared, you're totally
you're-
right.
because you factor out two.
Yeah. Seems sweet.
Abby,
Yes,
for the Y that you're working on, can you take a picture of the actual, like a table that you made or something for 2 plus I to the N? Let's actually talk about that Y for for the relationship between 6 and 7. Did you send me a picture of that? I don't think so.
I did send you a picture of that, but we stopped at N equals 5, but maybe we should keep going.
I think it's worth keeping going and keeping your solutions in a table. So like N equals 1, you have 2 plus I, and then you have that norm of 5, right? And then N equals 2, you have 2 plus I squared.
Oh, so you want us to write out, like, is there value of writing out more than N equals 2 is 3 plus 4I?
I think there is value. Yes. I think there's value if you want to understand the relationship between 6 and 7.
So you think we can see the relationship by looking at what we multiplied out?
I do. Yeah.
Okay,
I do.
so maybe we could each.
Yeah. I think it would be good if each of you did one of them.
Yeah. So no,
Maybe
just
it's wrong. This
yes,
is
you
like
are
not
getting
good
that wrong.
enough.
So she's saying that we need to show the work.
A
because-
little bit. You don't have to write out the whole computation like you're doing the distributive property all of those times. But
Can we
I
do
think,
it- Oh, sorry.
sorry, go ahead.
Can we do it recursively? Because I think that's how
Yes.
most of us would do it.
Yes, 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 yes. Do it recursively. Just make sure that you're writing it out in a way that's pretty organized. And I think the Y will fall out for you.
Okay, I think I'm gonna make my own table because.
Yeah, I'm hearing you. You don't like how I said my
No, I do. I can't. result is.
I could have said that. Honestly. I feel like I asked this before, and it makes me feel like I'm not being attentive. Is there a pencil sharpener on here?
And I think, yeah, very much.
So we the exact.
No, that's fine.
24 times 2 should be 48 somewhere, right? I did it. The real answer is always use the box
I got 42.85.
method. Math is ridiculous.
Wait, what did you get for that? For which one?
For n equals 5, I got the norm is 42.85.
Okay, for n equals 5, you got 2 plus I to the n is what?
Negative 62 plus 21i.
I think it should be negative 38 plus 41i. What'd you get for n equals?
Oh, never mind. Sorry. Yeah, I see. I had 38. I put the wrong. Yep.
Okay, okay.
I added against and multiplied.
You did that.
I did that.
Negative 38 plus 41i.
Yeah.
Which is. Which.
That's 31.
Four, 11, 24. Shauna, does that mean anything to you? I didn't mean to interrupt you. No, tell me when you're ready.
I have a question.
We're gonna be looking for a pattern in this, but we're gonna keep going. From this work, we can figure out like why something big about this, but I'm not sure what.
Yes, why something happens.
Yeah.
But actually, this I think is a handy teaching tool because it gives you a way to generate Pythagorean triples when you need them, and weird Pythagorean triples, not just 3, 4, 5, and multiples of that.
What'd you get for 6?
Negative 117 plus 41.
Okay.
So 44 or 30? I don't want to. I think I'm out.
No, I'm right.
That's okay.
I'm not right.
What did you guys get for 7?
We're not there yet.
Okay.
We're struggling to keep track of everything.
Yeah, I think that really keep track this time. You don't really have to keep track of every calculation, but you should keep careful track of the 2 plus I to the n.
Yes.
And then also what the norm is.
Oh, okay, also the norm.
I think I got, well, the norm is the hypotenuse.
Yes, that's something I don't understand, Shauna. I want you to explain that.
Is the norm 15,625 for n equals 7?
Yes, for n equals 6, 15,625.
And the result is negative 117 plus 4.
Yes. And then, you know what? I will just give you 7 and 8. Okay. So you don't have to spend so much time doing it. Wait, oh, sorry. Who's working on it?
No, that was a sigh of relief.
Okay. Okay. Yeah. That's enough. Negative 7 is negative 278 minus 29i. And the norm is 78,125.
Because these are the powers of 5.
These are the powers of 5. Okay, hold on. Last one, 8. Negative 527 minus 336i. And then it's 390,625. Aren't you glad you didn't have to calculate that one?
396,000.
620.
390,625.
So can you tell us the complex number for n equals 8 too?
Yes, negative 527 minus 336i.
Got it.
And then the end value is 390,625.
So it seems to me like something that could have been obvious to me a lot earlier, but maybe now it's like more obvious, is that you're doubling the number and then also multiplying it by I, which is super obvious. But right, because you're doing, like, when you do the calculation, if you go back to n equals 3, the calculation for 2 plus 11i is 2 times 3 and 2 times 4i, right? You're doubling that. Then it's just like the same as saying you're doing FOIL. I don't know. Do you get what I'm saying now? Anyone?
2, because you're saying 2 plus I times 3 plus 4i. So you're saying you're doubling 3 plus 4i because of the 2.
Yes.
So the 2 makes sure we double it each time.
Yes.
And then we also multiply by a factor of I each time.
Which I understand is super basic because like it's foiling, but also seems like you're doubling, right? Like there's a component of doubling.
So we doubled everything. Okay.
But
And
be
then-
careful, right? I mean, because you are multiplying everything through by I also, right?
Right.
So the calculation, you still have to use the distributive property pretty carefully. I don't really see an automatic shortcut there, honestly. Do you? I mean, you can do the calculation in your head, but you're still using the distributive property because
No, I think you're right.
Because the minus 1 you get with
I know it's annoying. It's
Kinda
like
messes
we're
it up.
yeah.
Okay, so now let's look at 7 together. Here is the thing about 7.
into squares.
What are some of the triples that you found so far?
That's
Sean
gonna be,
has, yes.
I think if you have a hypotenuse to find the diagonal triple, you just need to find the sum of 2 squares that equals that hypotenuse. And then you found a Pythagorean triple.
Yes, that's true. But
So-
that can be difficult. But so what did you get for A?
4 plus 1.
We're trying to be
So
one,
that's
Two,
1,
two.
1, 2. Yes.
But that's where these numbers are coming from, 2, 1, it's A and B. It's A, B values of this, yeah, 2 and 1.
Oh.
Right, 3 and 4.
So then this is 3 and 4, and then that's 5. because it's
Oh. Where's the-
You see the 3 and 4 in your table, right?
That's
And you see the 5 squared in your table, right?
Yes, that's the.
And then
size
for
of the
125, it's 2 and 11. 2
But,
squared.
but 125 isn't really anything squared, right? But 625 is something squared.
It's 25.
It's 25 squared.
7, 25.
Yeah. So you just use 7 and 24 and 25 and you get that Pythagorean triple.
So wait, I really need a
Here,
different
it's
color.
blue.
Okay. 7, 24, 6, 25. So then.
25 would be that.
25 is the hypotenuse, and 7 and 24 are the legs. But by the way, there is another non-primitive Pythagorean triple too, which is 15, 20, and 25, right? You can just multiply that 3, 4, 5 by 5 and get another one.
Right, because you're just introducing two fives.
That's right. That's right.
Which is all of seven, A, B, C, D. They're all multiples of the base 3, 4, 5.
So this is 3 squared, 4 squared, 5 squared. 3, 4, 5, 8. Did you just say that?
How about 125? Where do you see it in the end value chart?
When n is 3?
Yes, but the one that you actually care about is when it's squared.
I mean, because it's still 75, 100.
125 squared.
So you're saying like another Pythagorean triple is 1744, 125.
117, 44, 125. Yep, that's right.
That's
I mean, it must be so when you see it in the table this way, right? Because what you're doing really when you're finding that 2 plus I to the n, once you find 2 plus I to the n, and then you find the norm of that, you're really finding the hypotenuse of those legs. Right?
Because you
Yes.
did the norm of A squared plus B squared. And your answer ended up being,
So what about 625?
what's the algebraic answer to this? What was the norm of A squared plus B squared?
the norm of a squared plus b squared is a to the fourth plus b to the fourth plus 2a squared b squared.
Because it's not a square. Well, it's a multiple of an original.
But so if the hypotenuse is 125, it's a multi, we have to reduce all of it.
This is not equivalent to this 1, 3, 4, 5. So this 125 is
So what's 125 squared?
multiple.
You can use your phone.
You reduce
That's
all
the 3.
3, 4, 5.
It's 15,625.
This is 20, if you reduce all of them by 25.
Yeah. So so the 2 and 11 is just.
I'm sorry. I meant to ask what's 625 squared?
Right, it's just not an original.
It would be whatever.
It's a,
2, 11.
It's a multiple.
2, 11.
That's right. It's n equals 8. So that's,
like a triple from.
so what's the triple?
You can create.
Oh, yes. With 117.
I didn't get to write down those numbers.
527, 336, and 625.
Yes. It's really, it's gorgeous, right? Like, there they are. They just fall out for you. But do you see why? Like, is it totally obvious why?
625 squared is this. So we have 620. We have 527, 336, 620. Is that what you just said?
Yep, that's right. Sorry.
Mhm.
Or, I mean, yes, there's
So when we take the norm and we square it, then we go to that norm and the A and B will tell us what the others are.
I mean, if
25 squared, 625, so it's 25, 7, 25.
what it really comes down to is that like somehow multiplying with complex numbers is like maintaining distance in a really nice way.
It is the way the coordinate plane works, the Cartesian plane.
Yeah, but with that I thing, right? That's like really playing out for you somehow. That I times I is negative. You get what I'm saying? Like otherwise, like you can't. Is it the same with matrix multiplication? Not really. Otherwise, like how do you just multiply like 3, 5, and 2, 7?
Well, you kind of do, because think about it, when you do that, it's like AB minus CD.
Yeah, you're totally right, which is the same as the two eyes are becoming a negative one.
Sorry.
Good point.
That feels like a good moment.
Okay, you guys, let's take a break. 15 minutes.
Oh, yeah.
Take a break.
But can you explain that?
But you finished the important stuff, so you're on to neat stuff afterwards.
Yep.
Okay, so it's 5:40. So at 5 minutes to 6
Yeah.
Central. We'll see you.
Okay, cool. Okay. Anyone want pie? We have chocolate pie.
Oh, I do.
Okay. I'm gonna go get pie and plates.
Did I lie to you? I guess I did.
No, it's gonna be very easy. And I'm gonna.
Oh,
roast that
because the norm
Perfect.
of a complex number squared is the norm of a squared minus b squared. Oh, I'm sorry.
I think it's just this one. I'm doing this.
You're finding the norm of a squared plus b
No,
squared.
no, I'm doing the norm.
The norm isn't it just a complex?
The conjugate thing?
Yeah. What is
Yes.
a conjugate? Isn't the conjugate in this?
Yeah.
So shouldn't this be the value? Anyway, I'm gonna come back to this one.
Okay. I'm not. I just. I feel like I should bring it to you. My day was brutal. I had no preps. We went like
I went straight.
math team meeting, taught one, math team meeting, taught two. We did Pi Day through both of my lunches. Both of the lunches were both my preps. I taught 7 advisory, tutoring, and I'm trained catering. And like, oh wow.
I taught, had town meeting, which I hosted. Ooh. We had like 20 minutes of lunch, then we went upstairs to get ready for Pi Day. My day was crew, then I taught Sandy. Then did an hour after.
Those are awesome. Is this from your class? These
Yeah.
pyramids? Or, I don't even know if it's the right name. It's called something else.
Which one? Everything's, well, Abby has.
I just think these ones that look like you could have maybe made with cakes.
Yeah. Oh, yeah.
This looks fun. I wrote it there.
Yeah, so she definitely thought positive.
I don't think so, because that is just confusing.
So I interpreted what I meant to say.
You've been doing what?
I copy that and every day before work.
That sounds like punishment. What did you do wrong? Man, I wish your school had yoga. I would definitely go. This is a great flyer.
I'm taking it Saturday to a teacher job fair.
Oh, cool.
Yeah, I saw you guys are rehiring. Special ed for sure. And anyone else who leaves. So we're taking all opportunities. That's exciting. Well, yes. Maybe not next year. I've been 4 for the next year. So it's pretty open. It's like pretty much he thinks next year's expected. That's a pretty open one. Most people know.
Like, we're like hiring her consultants, because she runs her business
Is she named Shauna?
Yeah.
I remember that. I remember that she said that it was her.
This time,
And she spells it the same way?
yeah. Sean was here once over the summer before she met me. I guess Madeline met her, or they were all together. And I guess she did try to we love her and how it's a nice that like I really do like appreciate her. And Sean was like really and like now when she said Sean, I've never but she was like, yeah, there's something for her.
That sounds like a good idea.
And now that you know her,
She started. I hope you get it.
is it muted? No.
Sarah, we're back. And we're eating pie with pie. Can I show you this?
Yes.
This
I'm gonna be jealous, right?
I wish we could offer you this. This pie has a pie in it.
Wow. Wow. What kind of pie is it?
Salted chocolate chess. Oh, salted chocolate chess pie. It's from a bakery. Chess.
Someone told us what chess meant, but they were wrong.
Yeah.
What is it?
Butter, cornmeal, eggs, butter, butter. I took a picture at there's this bakery that donates pies to our school each year.
Valenti.
Yeah.
It's right off the
I know, you
outside.
should ask them.
Right
to donate to you too.
That's right next
You don't know, because
I'm
you're
sorry,
walking, there's little
I'm sorry,
balls
yeah.
and thank you letter. Super cute.
Yeah. Eggs, sugar, and cornmeal. And this version includes buttermilk.
Wow.
I wish we could send some to you.
It's like a brownie and a pie.
Wow. Sounds amazing.
Okay. So
Okay.
we're for meat stuff, and we're excited.
I'm hungry.
I have a question.
Oh,
Yeah, we hardly ever get to it, but I think these went really fast. So yay. Also, when you're at PCMI, you really have 3 full hours in the morning, right? Like you do get to the neat stuff at PCMI. I mean, all the times I've ever been, people have gotten to the neat stuff.
Yeah,
Not always, though.
no.
Not always.
Well, I think it depends. Like sometimes people go on their own project.
Like they decide to prove that the product of the norms is the norm of the product, or yeah.
Seems helpful.
It is. Actually, it's really helpful, and it might even be in here somewhere, honestly. All right, so neat stuff. Let's see. Should we pick some?
Well, actually, before I think there was one question.
Yes, go ahead.
This is one.
So
Yeah.
How do we get? I think the question is if we. I was thinking of this coming from the Pythagorean theorem, but it also comes from the conjugate is that. So those are the first, right, those are the legs of the triangle, it comes from the conjugates of any,
yes.
But
the
the
B value.
the legs are A and B.
The legs are A and B. So then how do you get the hypotenuse from these, or from these, algebraically? Like how would we see, oh, that's C squared?
Yeah.
How do we get that from this, the left side? Because A squared plus B squared should be equal to C squared. So C squared should come out of this, out of a complex number.
Well, I think this is the norm. So the norm doesn't equal the conjugate.
So what's the norm of that?
But to find the norm, we do a squared plus b squared. That's like the norm function.
We do this.
The norm is when we have this times this, that gives us the norm. But the norm has to be written in this form, but it's not like you take necessarily a squared plus b squared. It's like a squared plus c. So it has to be that form.
How does C squared come out? Like how does the value 5? Like my
I'm-
know this is
I'm wondering if this is helpful. I'm trying to think about what you're saying. But I don't have an answer, so I don't know if that helps. I'm thinking about like 3 plus 4i. And how I don't know how to model multiplying them, but I don't know how do you know that 9 plus 16 is going to end up being 5 squared. I don't feel like you do because like for some of this stuff, like these two things end up being 125. But that's not the square of anything. So I'm not
It's not
helping.
one of these.
Yeah, right. That's what I'm saying. This isn't helpful. But I'm just trying
Because
to
it's
process what you're saying.
I guess I'm asking, I see this, and I know then when I do the norm of this, my answer will be 25, right? That's this.
Okay.
But how do I go from this generalization of this to the generalization of that? Yeah.
Shauna, I don't know how you're trying to generalize, but I don't know if you can go in that direction, right? Because you don't always have squares in the hypotenuse column, right? It only works when you do have a square in the hypotenuse column. And you know you're going to have a square every time your n is even, right? When your n is odd, if you're working with a prime, you know it's not the square of anything. So you can't really generalize like every single column is going to give you a Pythagorean triple. Is that what you're trying? I'm not totally sure what you're trying to do, but is that it?
That's helpful. So, yes.
You can't generalize perfectly. All you can do is grab the useful stuff.
I don't choose. I think it's prime, it's odds, it's odd. Okay. Alright.
So basically all we know, like,
We could just pull out of it, the even values of n will produce.
Because this is 5 squared, 4, which is 25 squared.
I just want to see it kind of in this.
yeah, but I think that's important, like, what you're saying, a squared plus b squared is what gives that, like, I was trying to think of kind of like a concept map for it, because there's a lot more. Gives like the norm has to be in the form of a squared plus b squared, right? So that's this connection. I actually hate concept maps, but and then a squared plus b squared, like you were saying. And then this.
Do you guys want to do 10 and 11 in the neat stuff? Like, I think that might give you a way to generalize. At least it might. You could do a couple of them and then I will. You don't have to do all the computation. Don't tell Bowen.
Okay.
Actually, he's going to watch this. So I'm sorry, Bowen, that I am going to give them some of the solutions so they can actually get some of the good stuff. 10 and 11 in the neat stuff, I think is worth doing because I think, Shauna, the kinds of things that you're wondering about, it's not going to be, it doesn't answer exactly what you're working on, but it will at least give you a way to generalize that I think is more interesting.
Okay, cool. So that's awesome.
And you can, I think, again, it's just figuring out what you can get that's useful for you. And tell me when you get sick of computing. But make a table, like really make a table so that it's organized.
Yes, we're all in the table mode.
Yay, that's great.
Results. Because then I I think we are.
I'm working.
-9 plus 46. Thank you.
Okay, how's it going on the calculating? How,
We're still working. Still working. We're on like 3 and 4, and Jasper's gone rogue. It's okay.
well, I mean, part of the reason I wanted to do this is for Shauna, and the other reason is for Jasper. So you guys both will get something out of this.
That's what happens when you're too great eyes. I take that seriously. I have any was for it to check with you. I get a 10-19. Victory. I'm
Ladies.
actually at this point I'm doubling it. Just
That's 129.
yeah.
Sorry, what does that mean? You're doubling in the calculator? Is this like a huge showing? Is someone just getting reckless?
No, I'm
I'm calculating 2 things at once using the calculator.
No, I'm saying I'm multiplying by 2 in the calculator because I'm like that's where I'm at computationally.
Oh, I mean, these numbers are big.
Yeah, they are.
It's okay. I'll give it to you starting at 5. I really will.
Okay, I'm ready for 5.
Good, yeah, me too.
Okay, for 4, did you get negative 119 plus 120i, and you got 28,561, which, by the way, is 13 to the 4th.
Yes.
Oh.
All right. So for 5, if you did the calculation, you would get negative 597 plus 122i. And for the norm, you would get 371,293 equals 13 to the 5th, by the way.
Can I ask a question?
Uh-huh.
Do the negatives matter for norming? Like, can I just keep making these positives? Should I just do that myself? Am I too lazy? It feels like it has to matter, but once you take the norm, it doesn't matter. When we take our square rootable values, it doesn't matter either. I mean,
Well, it doesn't, yes, it does not matter. I mean, just think about the norm is giving you a kind of length, right? It's giving you the length of the complex, of the number on the complex plane, right?
Yeah.
It's calculating the distance of that line to the origin. So it doesn't matter in the sense that the distance from the origin doesn't really change between 4 plus 8i and negative 4 plus 8i. Those are the same distance from the origin, right? So that distance doesn't matter. But when you're actually taking the squares, or take the square and the 3rd power and the 4th power, then it is going to matter a little bit because you're doing something different. You're going to end up with something in the same distance.
But if we know the norm is multiplicative, I don't know, maybe that's wrong. It feels
Yes.
like you shouldn't,
So
because you just keep multiplying by, do you know what I'm saying?
I do. And for the norm, it doesn't matter. What you're going to get on the norms are the powers of 13, right? So what you found before is basically a corollary of your theorem from before is that powers of norms are norms of powers,
Yes.
right?
Yep.
Wait,
Abby.
so you're saying powers of norms are norms of power. Okay, so I see how that's connected to Jasper's. Powers of norms, I see that, 13 squared, 13 cubed, are norms of powers.
Like a norm of x to the power of something k is the same as the norm of x to the power of k on the inside.
Oh, yeah, okay, but that's connected to this or no? That's what
I was thinking it was connected. I guess I was asking because what we're doing, it feels like the outside knowledge that we're like constantly like infinitely outside applying is that we know that when we keep on multiplying in another thing that has a norm of 13, it's going to be increasing our total length times 13. So like when we're worried about like 13 to the 4, which was our last thing, that gave us the Pythagorean triple 119, 120, 169. Right? That was the one for n equals 4. That then now when we're gonna go up to 6, which is gonna be our next Pythagorean triple, we're like, I don't know if we're requiring it, but we're like kind of banking on it. It feels like it's back there being applied somehow, although I couldn't be super explicit right now about how it's being applied. But like we're adding in a factor of 13 2 more times when we 13 squared when we put in 2 more 3 plus 2 i's, right? And that's the whole. But I feel like I'm getting stuck somehow in the middle, like yeah. I don't know if what I'm saying is really helpful.
So I guess I'm having trouble connecting what you're thinking about right now to the question about the negatives. Like you don't have to worry about the negatives in the norm, right? Because you're just squaring them. And you don't really have to worry about the negatives when you're looking at the Pythagorean triple because you're looking at lengths. But I am confused about your question about why the negatives do matter in the 3 plus 2i to the n column. Because that's a complex number, right? And if you just change one of the negatives, it's a different complex number.
Agreed, but it's a complex number whose norm is so 169 squared. If you're thinking about like negative 19 and 120i. So I guess I'm curious what happens if you use positive 19 and 120i and then you multiply it by 3 plus 2i twice. Will you still get something with the norm of 13 to the power of 6?
Yes.
Which means you would get a different Pythagorean triple.
No, I think you might get the same. Yes, if they're not the same, but they may end up having the same absolute value.
I'm doing it.
Do it.
So, okay, so I want to make sense. I kind of get what you're talking about, but you do you.
Thanks.
I am so we know about this 13, so I'm wondering like how we can see 13 from the 3 plus 2i, like how did we get square? Oh. I see. Okay. And
That's good.
Let me just for myself.
No, by the way, that is, I mean, I don't know. I think you get to rediscover that over and over every time. Like, wait, where's the 13? Ah, yes.
Oh yeah, and there's the 5. Okay.
And there's the 5.
Okay, I see. So I was just gonna try 8 plus I because it's one of the ones that we've been seeing in problem set. It's gonna be 9 hours later. Right? Mm-hmm.
Wait, 8 plus I?
Powers of 65.
There you go. Yeah. So that's pretty big. You could do something like 1 plus 4i to do your check. That'll be a little smaller.
Well,
It's not going to be super small, but it will be smaller.
I guess I don't need to do that then, but I was just thinking back to Shauna's original question about like, why are we seeing 8 plus I and 43 plus 6I? Are those somehow like especially interesting or in number 2 in the important stuff? Like, why are those disliked numbers? That's the next question.
In number 2 in the important stuff.
Because we never answered that Shauna's big question.
Maybe is there to remind us they're not all complex.
Let's see.
When it comes to training.
I think that, so you have to, for some of these, you have to remember that some of the people doing these are middle school teachers. And even in our group, there are some elementary school teachers. So they have never done this calculation before. They haven't worked with complex numbers at all. So sometimes Bowen is just giving you things like this so you can see how, I mean, so for example, with the middle school group, when we did this together, they saw how this was kind of like rationalizing the denominator, right? Like that was a framework that worked for them. And they wouldn't have seen that if they hadn't actually done all this calculating. So they needed to do it in order to get a feeling for how the calculations with complex numbers work. So these, I think there's, I don't know, and I can ask him. Do you want me to ask him? But I think a big part of this is really just learning how these computations work. But I will ask him right now.
Well, in 2A and B, so if you see the answer for A, you'll see that appear as the denominator for B. So then
I see why you're, yeah, I see. But, all right, I'll ask him. I'm not gonna, I will, it's gonna take more than a text message, but.
just see, really, in relation to it. Why
Yeah.
Why was I understand why A, B, and D were included. Just not C. At least.
All right. I don't know if he'll get back to me, but hopefully. He'll get back to me before I see you again next week. The Pi Day thing was an easy, like, oh, yeah. All right.
So I checked them and they're different.
Yeah, they are different.
Yeah.
The norm should be the same though, right?
Yeah, that's what I'm checking now. Now I'm crushing on this TA30X.
I mean, maybe, so, okay, so we feel, everyone's feeling good about 10, right? 11, do you want to try find a Pythagorean thing? Oh, no common factors in whose corresponding.
Did we just do that in here?
Yeah.
Nice. 9, 46. Oh no, it'd be 13 to the 6.
Yeah,
whatever
so if you
equals
figure
6.
out 13 to the 6. That's exactly what you said, I'm sorry.
I think she gave us that.
Yeah.
She gave us 13
20,
to, but we can
35.
figure out 13 to 6. 13 to
I
6.
just calculated it. That's
So what
I'm
is
doing
it?
right now.
Oh, what is it?
Well,
I'm gonna take care of
no, it's not like
Reading this number, 4,826,809. So it should be that.
oh, got it.
And then just multiply this out.
You want what I got for that calculation or not?
Yeah.
I got negative 2035 plus 828i.
You say it again.
Yeah, negative 2035 plus 828i. Or if you had changed the sign halfway through in the middle of n equals 4, you would have gotten negative 845 and 2028. Which is cool because some of those digits are really close to each other, but they're definitely like very different. And so you get two different ways to make a Pythagorean triple with 13 to the 3 just by changing one of the negatives in n equals 4, which is if you like this one, I changed that to positive 19 and got a different answer. But you could have also, instead of changing this negative, changed that negative. So you have two negatives, and then if you like busted it through, you're just like,
Okay, you guys, we're gonna do so much of this next week.
okay.
Really. So don't lose the thread of it. All right.
So wait, the big picture is that we can change negatives, don't know why yet. Change positives to negatives, whatever.
Or vice versa.
Yeah, wow, I'm not very well.
Can I try writing it?
Yeah.
Alright, so think about this guy, right? Let's call him X, right? You go with that?
Yeah.
And when we do like X to the 4th, you got this. Cool? Right? But this thing, the norm of X to the 4th is the same as the norm of 119 plus 120. I do it a lot in class, which is the same as the norm of negative 119 minus 125, which is the same as the norm of negative 119, sorry, positive 119 minus 125. So we have like four different.
Okay, this I don't know.
Remember we did something last week where we were getting, as you're saying that, we were saying this is the same as this and this is the same as that.
Yes.
Oh,
We were saying
3, problems at 3.
you could get, yep, you can get.
You could choose something by like
It's like,
they had to add or something.
we did something that said,
Is from
with one number, you can then generate a
Yes.
whole bunch of.
Yes, and it was really weird. It was like the two, like it was 1 plus 4 is 9.
Yeah.
Sorry, 5 plus 4 is 9, but 5 minus 4 is
Then you
1.
would get, you could even like add and subtract them, whatever it was.
Yeah.
Like
I remember this really
4
well
and negative 1, and then it was
while remembering nothing at all.
1 and 4, and then 4, and you just keep changing one of the other ones, and you'd be getting another.
1, 3 is the
Yeah,
same as 3, 1.
Oh,
But it was also the
so
same.
it's as
But it was also the same as like 3, 5.
Yep.
Right? Do you remember that?
And
It was like a
it's
quadratic, so it was just like
Building a set of them.
this is gonna be it. This one. There's like a weird circle happening somewhere. No, dang it.
So a good lesson for us here is staying organized.
Should we label like 4 on the corner of each of these sheets?
I think we should, I almost feel like we should have a summary page.
We're gonna do one at the end of, I don't know when. I guess at the beginning of the next, not session 5, but at the beginning of session 6, I want to take some time and have each group reflect on the first 5 sessions. But can we spend the last 4 minutes a little bit off topic?
Yeah.
Because,
So Sarah wants to talk about.
I wrote to Al when you guys told me, and Bowen, to tell me that you guys were all PCMI teachers or once in future, right? And they were laughing. Matt and Al were laughing because I had told them I really want these New York teachers on our advisory board for this new project, and they'll be great. And they just all think the way we want teachers to think. They're blah 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 blah. And so today I wrote them that the reason I think that is you all have the stamp of PCMI. And so Al was like, yes. So he just wrote me back right now. Yes. What is the stamp of PCMI? So what is it about you, the way you guys think about things, that made me think, you're perfect. I had no idea that you went to PCMI and knew almost nothing about you guys, right? Except what courses you teach. So what do you think it is that you take away from PCMI that makes me think, yes, these are the teachers we want on our advisory board? Is it just a way of doing math together? Like, what is it?
I think like a big thing at PCMI that
I think possibly you gather all math teachers, like all of them, the ones that are willing to take that much time in the summer to study math,
Mhm.
have a not aptitude, but a different appreciation for it.
And then,
Or
yeah,
if
that's
there
true.
are other, I mean, I don't know if we're, because if you have families, like doing that is really difficult. It's a lot of time to dedicate towards enjoying mathematics in the summer. So your teachers that either can't do it because of family obligations and or have other interests that are they're not willing to put that much time into it. In the,
Mhm.
And there's math teachers who don't like math.
Yeah.
There's actually, I
they
think,
just
a lot.
fell into it.
Yeah. I think I used to be that math teacher, maybe in a way.
And what happened?
Yeah, I always say I'm better with numbers. I could have been an excellent accountant, but I'm a mediocre math.
I also feel like when you go to PCMI, you have this like huge amount of time that it's not that it's unstructured. I think it's like intentionally very openly structured. And spending like 3 weeks where it's like I just come in every morning and like all that's really required of me is that I try the opener. And then if I want to spin out on one thing for 2 hours, I could spin out in this little loop. But it also like I think teaches you to like kind of appreciate spinning out almost. You find your thing and then you're like, I'm just gonna be in this flow. And maybe like me and Ishrat are in that flow for 3 hours that day, but then like in 2 or 3 days I'm gonna sit with someone else and like try to like sync up with those people in a weird way. And I feel like that helps me appreciate this kind of like I feel like I'm prospecting or something. Like I think there's gold here. And then you're digging and then like maybe it works out or maybe it doesn't, but somehow when it does work out, it was so good that like all the like crappy digs made it okay.
Yeah, right.
Key too is like you don't like you have enough moments of success that you don't you value every question you have. And that helps you to like keep going. Like I feel like I had a few moments in PCMI where I felt like I was like behind or not getting it or something like that. And then from that I would ask a question or figure something out that moved the group forward.
Yeah. Yep, I do.
It was like something dumb or like I thought it was something kind of dumb or I was behind, but actually like you learn to value those things because that's what propels you forward and maybe the group.
I don't know if that's happening in the same way in the online groups, but it does happen in the online groups too, where somebody in one group asks a question that I think can move, that they think, oh, I just don't get this. And it actually pushes people in a different direction. I mean, because what they're trying to do is PCMI in a way that people who do have families and can't make it to Park City for 3 weeks can still get some of the benefit. It's not the same. You've already been teaching all day. So it's not like wake up, get fed, right? Do nothing but math. Yeah. But it's still, that's the goal of what we're trying to do. But this is really helpful. And thank you guys. I'm going to write to Al right now with your thoughts about dispositions of people who go and also that immersion piece and also that like prospecting for gold and the feeling of success and who contributes and how. It's a lot. All right. See you guys next week.
See you next week.
And Abby, I think I haven't sent you session 5, but I will.
I don't think so. Yeah.
I had sent you 4, but I think I decided on 5. All right. See you later. Bye, everybody. Thank you so much.